Welcome back, everyone, to yet another deep dive into the world of tech and AI. In our last session, we took a deep dive into one of the most important aspects of the fourth industrial revolution, how it's reshaping the job landscape. We explored the kinds of jobs likely to be lost and gained by 2050, driven by technological advancements, automation, and AI. We also discussed the impact of climate change on employment, touching on the new opportunities it's creating in green energy and sustainability, as well as other potential job gains and shifts emerging from this transformative era.
That's right. It was a thought-provoking conversation about the future of work, filled with both challenges and opportunities. If you missed it, I'd highly recommend going back to listen, especially if you're curious about how the fourth industrial revolution will affect your career or your industry.
Today, we're taking the conversation a step further, diving into the heart of what's driving this revolution: data and AI. We'll talk about the future of AI between now and 2050, exploring concepts like artificial general intelligence, the technological singularity, and the pivotal role other scientific disciplines like neuroscience might play in advancing AI.
We'll also examine how the first three characteristics of past industrial revolutions, mechanization, mass production, and digitization, are showing up in this fourth wave, and how they're setting the stage for unprecedented innovation.
And guiding us on this journey is the brilliant book, The Fourth Industrial Revolution and 100 Years of AI by Dr. Alok Aggarwal. It combines deep insights into the history of AI with a forward-looking perspective on where we're headed, offering a fascinating roadmap for understanding this era of transformation.
There's so much to unpack, so let's get started. From the imitation game to the potential of artificial general intelligence, we'll explore how AI is not just mimicking human thought, but pushing the boundaries of what machines can achieve.
Let's dive straight into something fascinating. Does the language we speak shape the way we think?
It's like a chicken and egg scenario, isn't it?
Totally. We're using language to explore the power of language itself. And one of the biggest questions in artificial intelligence is whether understanding language could be the key to creating machines that think more like humans.
You mean machines that don't just follow instructions but can actually think critically, adapt to new situations, and understand things like humor or emotions?
Exactly. That's where artificial general intelligence, or AGI, comes in. Right now, we have AI that can beat grandmasters at chess, but it can't explain its strategy in human terms or adapt that skill to a completely different problem. AGI, on the other hand, could think, reason, and learn across a broad range of tasks, like a human.
But we're not there yet, right?
Not quite. One of the big hurdles is teaching machines to truly understand language, not just mimic it. Passing a Turing test, for example, convincing a human you're human through conversation, doesn't necessarily mean a machine actually understands what it's saying.
It's like teaching a parrot to say good morning. The parrot can repeat the phrase, but it doesn't understand what mornings are or why we greet people.
Exactly. And there's growing evidence from fields like linguistics, psychology, and anthropology suggesting that language isn't just a tool for communication. It's deeply connected to how we perceive and think about the world.
One fascinating example comes from studies of the Munduruku people, an Amazonian tribe whose language has very few words for quantities. Trying to explain the difference between 10 apples and 12 apples to them is incredibly challenging because their language doesn't support those precise distinctions.
So if your language lacks the words for a concept, it might limit your ability to fully grasp it. That's pretty mind-blowing.
It is. It suggests that language and thought are deeply intertwined. If we want to create machines that truly think, we might need to teach them not just grammar or vocabulary, but how language influences thought itself.
Here's something fascinating. How does the language we speak influence the way we think?
It's a big question, and it goes deeper than just communication. For example, in English, we often think of time as moving left to right, while in Mandarin, it's conceptualized vertically, from top to bottom. Research shows this difference in language actually shapes how speakers of each perceive time, even when they're speaking other languages.
That's mind-blowing. If language can shape something as fundamental as time perception, what else could it influence?
Exactly. This has huge implications, especially when it comes to creating AI. If we want AI to understand the world like we do, it needs more than just vocabulary and grammar. It needs to grasp how language shapes thought itself.
But where do we even begin? Teaching a machine to understand language on that level sounds like trying to explain poetry to a calculator.
It's a monumental task, no doubt, but here's the advantage. We're the ones designing AI. That gives us the ability to guide its development, ensuring it mirrors the depth of human understanding rather than just mimicking surface-level patterns.
So we're not just watching AI evolve on its own, we're actively shaping its future. But what about the risks? There are always concerns about AI becoming uncontrollable or even dangerous.
Those concerns are valid, but they're manageable. Just as architects design buildings with safety in mind, we can design AI with safeguards and ethical frameworks. It's about making intentional choices to prevent dystopian outcomes.
That makes sense, but it's still a huge responsibility. If we're essentially creating a new form of intelligence, how do we ensure it aligns with our values and vision?
That's where collaboration comes in. Instead of viewing AI as a threat, we should see it as a partner. By combining AI's analytical power with human creativity, empathy, and wisdom, we can create systems that amplify our abilities instead of replacing them.
So AI doesn't have to replace us. It can enhance what we're already capable of. But doesn't that bring up a whole new set of ethical challenges?
Absolutely. For instance, advancements in areas like cognitive enhancement or AI access raise tough questions about fairness and equity. Who benefits from these technologies? How do we ensure they're used to uplift everyone, not just a select few? These are issues we need to tackle as we move forward.
It seems like every answer just leads to more questions. But I guess that's the nature of exploring uncharted territory.
Exactly. This isn't about having all the answers, but about sparking a conversation on the future we're creating. It's a call for a more thoughtful, human-centered approach to technological innovation.
As we develop these advanced AI systems, it's crucial to remember that technology is a tool. It's up to us to decide how we use it, the values we embed in it, and the kind of future we want to shape with it.
That's key. AI should empower humanity, not diminish it. Imagine a future where AI becomes a true partner, helping us solve complex problems, drive scientific breakthroughs, and even achieve a deeper understanding of ourselves.
That's a future I can definitely get behind. But how do we bridge the gap between today's AI, which struggles with basic conversation, and AI that can collaborate with us on such profound levels?
That's the ultimate question. We're talking about AI that truly understands language, not just mimics it. If AI can grasp the nuances of language, could it also understand humor, emotion, or even consciousness?
That's a huge leap. Right now, it feels like we're standing at the edge of a vast unknown. The potential benefits are enormous, but so are the risks.
Absolutely. And it raises profound questions about intelligence and consciousness. If language shapes thought, then creating AI that deeply understands language could redefine what intelligence means.
It's like we're not just building AI in our image. We're using AI to better understand ourselves. That's both exciting and a little intimidating.
That's natural. But there's also a hopeful perspective. As AI learns to process language, make decisions, and understand the world, it can act as a mirror, giving us insights into how we think, communicate, and make sense of the world.
So it's not just about teaching AI, it's about learning from it.
Exactly. Imagine AI breaking cultural barriers by not just translating words but the subtle nuances of meaning, or making complex ideas accessible to everyone.
It could become an incredible tool for communication, understanding, and connecting people and ideas.
And in teaching AI about language, we might uncover something even more profound about the extraordinary power of the human mind.
So, what would you say is the biggest takeaway for our listeners so far? What should they be thinking about after this discussion of Dr. Aggarwal's work?
I think the biggest takeaway is this. The relationship between language and thought is far more complex and profound than we often realize. And as we develop increasingly sophisticated AI, it's crucial that we consider the implications of this relationship.
So it's not just about teaching AI to speak. It's about understanding how language shapes our perception of the world, our values, our very sense of self.
Absolutely. And as we venture further into the uncharted territory of artificial intelligence, let's remember to approach it with both curiosity and caution, with a deep respect for the power of language and a commitment to shaping a future where technology serves humanity.
Well said. Okay, so let's move past the AI hype and explore one of the most radical ideas out there, The future of AI might actually depend on understanding the human brain. We've all heard about deep learning. It's been the star of AI research for years. But even pioneers like Geoffrey Hinton and Yann LeCun admit it's hit a wall.
Exactly. Take something like translating a complex novel with deep learning. Sure, it might deliver a technically accurate translation, but the nuances, emotional depth, and the author's unique voice, those would be completely lost. Deep learning is fantastic at recognizing patterns, but it struggles to grasp context or apply knowledge creatively.
So it's like deep learning is a brilliant student who can ace any test, but can't write a compelling story or understand a joke.
Exactly.
And that's the crux of the issue. If we want AI to solve truly complex problems, innovate, or even begin to understand the world as humans do, we have to go beyond mimicking the brain's structure.
Right. We need to understand how it actually works.
Take something as simple as the roundworm C. elegans. It has only 302 neurons, and yet we still don't fully understand how its nervous system functions.
Exactly. Even this tiny worm demonstrates the staggering complexity of even the simplest brains. Not just about individual neurons firing, it's about interconnected circuits, changing states, and a dynamic flow of activity.
It's like looking at the blueprint of a building and trying to figure out how people live inside. We need to see the daily routines, the interactions, and the flow of life to truly understand how the building works.
That's a great analogy.
So how do we translate that complexity into AI research?
Two areas of the brain stand out as particularly inspiring for AI: neuromodulators and brainwaves.
Neuromodulators and brainwaves. Those aren't exactly terms you hear every day in AI discussions.
That's because they represent a radical departure from traditional AI thinking. Neuromodulators are like the brain's chemical messengers. They fine-tune how neurons respond to signals, dynamically adjusting the brain's processing. If we could incorporate a similar mechanism into AI, it could lead to systems that learn and adapt in more nuanced ways. Imagine an AI that fine-tunes its learning process in real time based on context, almost like it has a sense of feeling.
Wait, chemicals and AI? Are we talking about moving beyond silicon into something out of science fiction?
It might sound far-fetched, but exploring new paradigms often does. Think about how quantum physics revolutionized our understanding of the universe. What if bringing elements of chemical processes into AI triggers a similar transformation?
And brainwaves? They're like the electrical symphony of the brain. We know they're patterns of electrical oscillations, but replicating something so complex in AI seems almost impossible.
It's definitely a massive challenge, but think of it this way. We've already created AI that can recognize faces, translate languages, and even generate poetry. Brainwaves are just another level of complexity. It's like we've learned to play individual piano notes and now need to compose a full concerto.
So if we could decode how brainwave patterns orchestrate complex thought, we might be able to create AI that doesn't just process information, but thinks more like we do. That's an exciting prospect.
It is, but we're still in the early stages. Understanding how the brain uses neuromodulators and brainwaves is a monumental task. There are immense technical and conceptual challenges to overcome before these ideas can be applied to real-world AI systems.
It's like standing at the foot of a mountain with a glimpse of the summit, but a long, winding path ahead. If we can make the climb, it could lead to a revolution in AI unlike anything we've seen before.
Absolutely. To see why this journey is so important, we need to look at some of the groundbreaking research paving the way for this brain-inspired future of AI.
Okay, we've established that the human brain might hold the key to unlocking the next level of AI. But how do we even begin to decipher the secrets of something so complex? It's like reverse engineering the most sophisticated computer ever created.
It's daunting, but there are ambitious research projects that are already providing glimpses into how the brain works. Projects like Micron's, the Brain Initiative, and the Human Brain Project represent the cutting edge of neuroscience.
Let's start with microns, mapping an entire rodent brain down to the level of individual synapses. That sounds like an enormous undertaking.
It is. Rodent brains might seem simple, but they drive remarkably complex behaviors. Navigating mazes, learning tasks, even social interactions. Microns aims to map how information flows through this intricate network of neurons and synapses, providing a detailed wiring diagram of the brain.
So it's not just about understanding individual components, but how they work together as a system.
Exactly. It's like studying how a city functions by analyzing traffic patterns, communication networks, and the flow of people and goods.
By understanding how a rodent's brain processes information, we could uncover principles of intelligence that inform the design of more adaptable AI systems.
That's the idea.
And what about understanding the human brain? That's where the Brain Initiative and the Human Brain Project come in, right? But mapping the human brain with billions of neurons sounds almost impossible.
It's a massive challenge. The Brain Initiative, launched in 2013, uses innovative technologies to record activity from vast networks of neurons simultaneously.
So instead of studying neurons individually, it's like listening to an entire orchestra instead of just individual instruments.
Exactly. The goal is to understand how brain regions coordinate complex functions like learning, memory, and decision-making.
And the Human Brain Project is taking a different approach, trying to build a computer simulation of the brain. That's like creating a digital twin of our minds, isn't it?
In a way, yes. They aim to simulate the behavior of real neurons and synapses digitally. This could allow researchers to test theories about how the brain learns and adapts, potentially revolutionizing our understanding of neurological disorders and offering insights for AI development.
These projects are so ambitious, it's mind-boggling.
They are, and while the challenges are immense, the potential rewards are equally staggering.
They're certainly pushing the boundaries of what's possible. But think about the progress we've made in other fields like genomics and space exploration.
A few decades ago, sequencing the human genome seemed impossible. Now, it's routine. Landing a rover on Mars was once science fiction. These brain research projects represent the next frontier of scientific exploration.
Even if they don't achieve all their ambitious goals, the knowledge and technologies they generate along the way will be invaluable.
Absolutely. Just like the Apollo missions spurred advancements in computing and material science, these projects are driving innovation in imaging, data analysis, and simulation. The ripple effects could transform fields like AI, medicine, and robotics.
It does feel like a scientific revolution in the making, one that could fundamentally change how we understand ourselves and our place in the universe.
We're on the cusp of a new era of discovery, one that could unlock the secrets of consciousness, intelligence, and perhaps even the nature of reality itself.
It's a thrilling time, but as we talk about replicating the brain or building digital versions of ourselves, there are definitely ethical considerations.
Absolutely. With any powerful technology, there are risks and unintended consequences to consider. The ethical implications of brain-inspired AI are as significant as the scientific challenges.
We're holding a key to incredible potential, but we need to be responsible in how we use it.
Agreed. But let's shift focus. How might the findings from these research projects translate into real-world AI advancements?
That's the big question.
By studying how the brain learns, adapts, and solves problems, we could create new algorithms and architectures for AI. For example, the brain's ability to form and retrieve memories could inspire new approaches to data storage in AI.
Or its energy efficiency. Imagine more sustainable AI systems.
Exactly.
We've explored the limits of AI and these massive research efforts to crack the brain's code. It's a lot to process. What's exciting is that innovation often comes from questioning assumptions, even those that seem fundamental.
Exactly. Who knows, in a few decades, our current AI systems might seem as outdated as those old computers with punch cards.
Here's what I wonder. If the human brain, with all its biological quirks, achieves such intelligence, what other natural systems might hold clues for AI development?
That's a fascinating question. We've only scratched the surface of what nature can teach us.
It's like we're trying to build a rocket from scratch, ignoring that birds have flown for millennia. Maybe creating intelligent machines isn't about perfectly mimicking our brains, but learning from the vast diversity of intelligence in the natural world.
Exactly. Studying those diverse forms of intelligence could not only revolutionize AI, but also deepen our appreciation for the interconnectedness and complexity of life itself.
Wow, that's deep. Okay, not to shift gears, but we've been talking about the fourth industrial revolution. The big question is, are we really in the middle of something as massive as the invention of electricity? Or is it just hype?
That's the big debate. What makes this period feel genuinely revolutionary are three key characteristics: data becoming a core resource, AI becoming widespread, and a rapid succession of groundbreaking technologies. It's comparable to the transformative shifts we've seen throughout history.
Let's set the stage. Can you quickly recap the first three industrial revolutions?
Sure. The first industrial revolution was about harnessing water and steam power to mechanize production. Think steam engines and power looms. The second was driven by electricity and mass production, introducing assembly lines and huge manufacturing advancements. The third is the digital revolution: computers, the internet, and the rise of information technology.
Got it. Now, let's dive into this fourth industrial revolution. The first characteristic that stood out is the idea of data infrastructure becoming as essential as electricity. What does that mean?
During the second industrial revolution, electricity became a fundamental utility because it powered everything. Today, data is playing a similar role. It's not just about collecting and storing data. It's about making it findable, accessible, and usable. This infrastructure supports AI algorithms, connects systems, and drives innovation across industries.
How does that translate to everyday life?
Let's take healthcare as an example. A strong data infrastructure could give doctors instant access to your complete medical history, regardless of where you've been treated. AI could then analyze this data alongside genetic, lifestyle, and environmental factors to provide personalized medicine and even predict health risks before they arise.
That's a game changer. What about other areas like cities?
Think smart cities. With robust data systems, cities could optimize traffic flow in real time, reducing congestion and pollution. That means shorter commutes, cleaner air, and better resource management.
That's impressive. But what's this about things like domain ontologies and expert systems?
It sounds complex, but it's actually straightforward. A domain ontology is like a digital dictionary for a specific field, medicine or transportation, for instance. It organizes key concepts and relationships so computers can understand and use that knowledge effectively.
So it's about creating systems that truly understand specialized information.
Exactly. It's the foundation for smarter AI and better decision-making across industries.
So it's like teaching a computer to speak the language of medicine or transportation.
Exactly. And that's where expert systems come in. These are AI systems trained on specific domain knowledge. For example, imagine an AI-powered traffic management system. It doesn't just analyze real-time traffic data. It understands how roads, traffic patterns, and even weather conditions interact. It could predict and prevent traffic jams before they even happen.
Whoa, that's like something out of a sci-fi movie.
It really is.
But with all this data flying around, what about privacy?
That's a critical issue. A key aspect of modern data infrastructure is decentralization, meaning data isn't stored in one central location. This reduces risks of security breaches and system failures. On top of that, advancements in encryption and security technologies are continuously improving data protection in this increasingly interconnected world.
That's reassuring. Okay, let's move to the second big point: the AI explosion.
Right. AI is finding applications in nearly every aspect of life. There are so many use cases emerging that it's reshaping industries in ways we couldn't have imagined.
Can you give some unexpected examples?
Sure. Take education. Imagine AI tutors that adapt to your learning style, identify gaps in your knowledge, and provide personalized feedback. This could make education more engaging and accessible for everyone.
That's really interesting. What about something like the legal field?
Absolutely. AI can analyze legal documents, research case law, and guide people through complex legal processes. This could make legal services more affordable and accessible, leveling the playing field for those who can't afford traditional representation.
That's a powerful example. But what about the downsides?
There are definitely challenges. One of the biggest concerns is job displacement as AI automates tasks previously done by humans. It's something that needs proactive solutions.
So how do we prepare for this AI-driven future?
It's about shaping the future, not just preparing for it. We need to use AI to complement human skills and create opportunities. Investing in education and retraining programs focused on skills like critical thinking, creativity, and complex problem-solving will be key.
So it's less about humans versus machines and more about collaboration.
It's about thoughtfully integrating these technologies to benefit everyone.
That's a great perspective. And speaking of emerging technologies, some of what's coming out now really does feel like it's straight out of science fiction. Flying cars. Are we really on the verge of personal skyways?
It might be closer than we think. The technology behind flying cars has advanced significantly, especially in electric propulsion, autonomous navigation, and air traffic management systems tailored for these vehicles.
So, it's not just strapping wings onto a car?
No, it's much more complex. Integrating these technologies while ensuring safety on a whole new level is a massive engineering challenge. But prototypes are already being tested, and in a few years, we could be checking traffic reports for the skyways alongside the highways.
That's a fun thought. No traffic, right? What other inventions caught your eye?
One exciting area is the convergence of biotechnology, AI, and nanotechnology. The idea of microscopic robots that could deliver drugs directly to disease cells like cancer is fascinating.
It's like having a tiny doctor inside you.
Exactly. These nanobots could minimize side effects and revolutionize disease treatment. It's still in early stages, but the possibilities are incredible.
It really does sound like science fiction, but if it becomes a reality, healthcare could be transformed.
Absolutely. There's also gene editing, like CRISPR, which is making huge strides.
Yes, it's been in the news a lot.
CRISPR allows scientists to make precise DNA changes, potentially curing genetic diseases that were previously untreatable.
It's definitely a promising area of research.
It is, but it comes with ethical concerns. Gene editing has great potential, but we need open discussions and clear guidelines to ensure it's used responsibly.
So it's not just about the technology, but the values guiding its development.
Exactly. The fourth industrial revolution is not just about technology. It's about reshaping how we work, learn, and live in a world increasingly influenced by intelligent machines and groundbreaking scientific advancements.
That brings us back to job displacement. While these inventions are exciting, the challenges of rapid technological change can't be ignored.
Absolutely. The key is to adapt alongside these technologies. We need to invest in education and retraining programs to equip people with the skills to thrive in this new economy. Lifelong learning and upskilling are crucial.
So, instead of fearing the future, we need to embrace its potential.
Exactly, and shape it in a way that benefits everyone.
Yeah, exactly. These technologies are tools. It's up to us how we use them.
That's right.
We have the power to shape this revolution into something that creates a more equitable, sustainable, and prosperous future for everyone.
Well said, I couldn't agree more.
I want to go back to something you mentioned earlier: domain ontologies and expert systems.
Ah, yes, those terms.
They sound complicated.
They do, but they're crucial in making sense of the massive amounts of data we're generating.
Right? So, domain ontologies are like creating a cataloging system for all this data?
Exactly. They help us organize and structure data in a meaningful way. For example, a healthcare ontology could define types of medical conditions, treatments, and patient characteristics, creating a common language that allows different systems to communicate and share information seamlessly.
Got it. And expert systems actually use that information, right?
Exactly. An expert system is an AI trained on a specific domain ontology. It can make decisions based on that knowledge. For instance, an AI-powered diagnostic tool could analyze a patient's medical history, symptoms, and genetic information to help doctors make more accurate diagnoses.
So by combining domain ontologies with AI, we create systems that don't just process data, they understand it and apply it in real-world situations.
Exactly. It's about making data intelligent and actionable, which is the real power of this revolution.
Okay, I think I'm starting to understand the significance of these concepts.
It's definitely a lot to take in, but it's fascinating.
It really is. It shows how interconnected all these technologies are.
Right? It's not just about individual inventions, but how they all come together to shape the future. And this revolution isn't just a short-term trend, it's a long-term transformation.
Absolutely. The pace of change is accelerating, and the possibilities are limitless.
It's exciting, but a little daunting too, right?
Definitely. But it's also an incredible opportunity to shape the world we want to live in.
Exactly. We can harness these technologies to solve some of the biggest challenges humanity faces and create a more equitable, sustainable, and prosperous future for all.
It's powerful and inspiring. We've covered a lot, from the essential data infrastructure to the explosion of AI applications and the ethical questions that come with it. And we've touched on the exciting inventions already shaping this revolution. There's a lot to look forward to. I mean, those inventions really capture your imagination, right? It's like catching a glimpse of the future that seemed like science fiction just a few years ago.
Absolutely. It's exciting to think about where these technologies could take us.
Let's talk about one you mentioned, gene editing, like CRISPR. We've already discussed its potential for curing genetic diseases, but where do you think this technology is headed?
The possibilities with CRISPR are huge. It could help engineer crops resistant to disease and drought, leading to better food security. Or imagine using gene editing for biofuels and sustainable materials to reduce our reliance on fossil fuels and fight climate change.
So it's not just healthcare. CRISPR could impact multiple industries?
Exactly. And beyond fixing things, some researchers think CRISPR could enhance human capabilities, improving lifespan, cognitive function, and disease resistance. But of course, that brings up some important ethical questions we'll need to address.
Definitely. We need those discussions alongside scientific progress.
Absolutely.
Another hot topic is quantum computing. How do you see that shaping the future?
Quantum computing is fascinating. It could revolutionize fields that require complex calculations and simulations like drug discovery, material science, and financial modeling.
Can you explain how it works? It sounds complex.
It is, but I'll try to simplify it. Traditional computers use bits, which are either 0 or 1. Quantum computers use qubits, which can be both 0 and 1 at the same time. This is called superposition.
Whoa, really?
Yes, it's mind-bending. This superpower allows quantum computers to perform calculations much faster for certain types of problems, opening up possibilities for solving issues that are impossible for today's supercomputers.
So how could this impact something like drug discovery?
Imagine being able to simulate millions of molecules to identify potential drug candidates far quicker than we can today. This could lead to new treatments and even prevent diseases before they develop.
Quantum computing could really change healthcare.
Absolutely. And it could also lead to breakthroughs in material science, designing lighter, stronger, and self-healing materials.
I'm sold. And what about 3D printing? We've seen some cool things already, but where is this technology headed?
3D printing is already used for prosthetics, jewelry, and architectural models. But in the future, we could see entire houses printed on demand using sustainable materials and tailored to individual needs.
That would transform construction.
It really would. Plus, in healthcare, 3D printing could create personalized medical devices and even human tissues and organs, which would be a game changer for organ transplants and regenerative medicine.
Incredible. With 3D printing, it feels like the only limit is our imagination.
Exactly. And that's what's so exciting about this revolution. It's not just about individual technologies, but how they all come together to create possibilities we couldn't have dreamed of before.
This has been an amazing dive into all of these technologies. It's clear that we're living in a time of incredible technological advancement. So, what's the key takeaway you hope listeners walk away with?
The future isn't something that just happens to us. We have the power to shape it. This revolution brings both incredible opportunities and challenges, and it's up to all of us to engage in these conversations and think critically about how these technologies affect our lives. Together, we can create a future that benefits everyone.
That's an inspiring message. As we wrap up today's discussion, we've covered a lot of ground about the exciting and transformative future of the fourth industrial revolution. From the rise of AI and data-driven systems to the possibilities of artificial general intelligence and the looming idea of technological singularity, the potential changes ahead are vast and complex.
Absolutely. We explored how the intersection of AI, neuroscience, and other scientific disciplines might unlock new frontiers for machines to think and learn like humans, while reflecting on how the first three characteristics of industrial revolutions, technological advancement, economic transformation, and societal change, are already emerging in this fourth industrial revolution.
It's clear that we're at the threshold of a massive shift, one that's going to reshape industries and redefine our future. But as we've also seen today, this revolution brings both immense opportunities and challenges, and it will require us all to be proactive, thoughtful, and engaged in the dialogue as it unfolds.
That's right. And in our next session, we'll take a closer look at how innovations, while incredibly powerful, often take time to truly seep into society. As we've seen in past revolutions, the euphoria that surrounds new technologies can lead to boom and bust cycles. We'll also discuss the crucial roles that governments, academia, and private investors will play in shaping the direction of these technologies and ensuring their responsible development and integration.
It's going to be a fascinating conversation, and we hope you'll join us next time as we dive deeper into the future of innovation, its societal impact, and the roles each of us can play in navigating this transformative era.
Thanks for tuning in, and as always, keep learning, stay curious, and embrace the possibilities of the future. We'll see you in the next session.